going to take a look in section 2 of chapter 5 of quadrantal angles. Now these are angles that end at the axis here. So you could have always start, you know, at the positive x-axis. So what if we do if our angle ends at our positive y-axis? Well, that would be a 90-degree angle. And we could pick any point on this y-axis here. The most easy one is 0, 0, 1. My x is 0, my y is 1. I could have this could end right here. Negative 1 comma 0 could end down here. So this one right here would be 180 degrees. The one that wraps all the way to here is 270. And then finally all the way around, if it wraps all the way around, it's 360 degrees. And that could be point 1 comma 0, and then this point down here would be 0, negative 1. Well, and these are called quadrantal angles. And it's where your terminal side ends at an axis. Okay, so we could find at 90 degrees. Here's our 90 degrees. So we have our x equals 0 and our y equals 1. That means our r would also equal 1, right? Because 0 squared is 0, 1 squared is 1, 0 plus 1 is 1, and the square root of 1 is 1. Okay, and that's really the same for all of these, isn't it? Isn't the r just the distance to 0? Distance to 0 is 1, distance 0 is 1, 1, and 1. So all my r's for these 4 points is 1. So 90 degrees. And we look at sine of 90. That is going to be our y over r. Cosine of 90 is x over r, which is 0. Tangent of 90 is y over x, which can't divide by 0, so that's undefined. We could do their reciprocals. Cosecant of 90. Cosecant of 90 is still 1. Secant of 90 equals undefined, right? Because I'd be flipping 0 over 1, so that'd be 1 over 0. So secant of 90 is undefined. And cotangent of 90 would be 0 over 1, which is 0. Okay, so those are of 90 degrees, and you can do similarly with 180. It's just a negative, right? So that means your cosine would be negative, right? And your tangent would be 0, and your cosine would be negative 1, and your sine would be 0. So you could do all these, so you can make a chart, you know. You have your 6 trig functions, you know, sine, cosine of theta of some angle, tangent, their reciprocals. Okay, and then you have your thetas. Right, these are your thetas. 90, 180, 270, 360, or 0. And you can go ahead and make your chart. So like we said, sine of 90 is 1. Secant of 90 is 1. Cosine is 0. Secant is undefined. Tangent is undefined. And and cotangent is 0. As we look at these, most of these are all the same, right? Or they kind of just switch kind of order, right? This one would be 0, this one would be -1, tangent would be 0, secant would be undefined, and then secant would be -1, and then cotangent would be undefined. So you notice how they just switch, right? Same thing with sine. It comes back. This time it's negative. This time this is 0, right? Tangent again is undefined because my x is 0, right? Cosecant would be -1. Secant would be flipping cosine, so that would be undefined. And cotangent would be back to 0. So we can see how they're just kind of rotating back and forth. What do you think 0 and 360 are? At 0, this time it's +1, 0, undefined, back to +1, and then we have undefined as cotangent, because that is x over y, and our y is 0. So that's kind of how 80, 90, 80, 270, and 360 look for 0. Okay, so you can use that to help you find the different trig functions when you evaluate those. So these you kind of use that point 0, 1, 1, 0, -1, 0, and 0, -1, right, for these different 80, 80, 180, 270, and 360, and that's how you can find them all, right? So as we look, so let's go ahead and work on some problems here. Page 497. We're starting on 496. Let's start with number 9. We're going to do number 9, number 45, 47, 51, and 53. Let's start with number 9. Let's find the values of the 6 trig functions going through this point. So we have our initial side, and it's open up 0, 2. That's 1, 2. So it's right here. So 0, 2. So find your r. Here your r would be 2, right? Because what's the distance? 2, 0 is 2. So your r equals 2. You have your x and you have your y. Find all the 6 trig functions. This is pretty easy because it is 90 degrees, right? So one of the 6 trig functions, no matter where. Because if this is 0, 1, this angle is 90 degrees, right? Theta is 90 degrees. Well, if I'm opening from here to here, isn't that still 90 degrees? So those 6 trig functions that you just found, isn't it still finding sine of 90 even though I'm at this? Right, it's just reduced to my y over my r. Wasn't that just reduced down to 1? Wasn't that sine of 90? Right, so all these are the exact same as the problem that we just got done doing. So those are the exact same. You're just going to have to reduce your fractions here, right? So you're going to get 2 over 2 for cosine of 90. Right, you're going to get 0 over 2, which still reduces down to 0, and tangent is still going to be undefined because you have your y over your x, which you still can't divide by 0. And then so you can go ahead and find the other 3 remaining ones by flipping those fractions, and they'll be the same answers we just got done doing. Okay, let's take a look at number 45 and find tangent of 180. And really, I already found these for you, right? We just did this whole thing. So tangent of 180, you can look right here. So if that point is -1, 0, there's your x, there's your y. What's your r? Your r is 1. So there you go, find tangent. It's your y over your x, right? Which is 0. Okay, and then we can look at, I think, 47. Secant of 180. We already did this. Secant would be r over x, so that'd be -1. Then we can look at this chart that we just did. You can look at 51. Also, here's a little bit different. 51 is cotangent of 540. Well, how many 360s do you have there? So 540 means you go around once. That's once 360, right? So 540 minus 360. Add 60 more. Add 80 gets you to 40, and then 180. So isn't that just 180? So cotangent of 540 is the same as cotangent of 180, right? Those are coterminals. So that'd be the same as flipping your tangent of 180, which would be undefined. Okay, and then 53. Cosecant of negative 450. And here again, you could add 360. So you could add 360 to that. Probably have to add 360 twice, right? Because that's negative to get that coterminal of least positive. I mean 361, so that's fine. So if you could add 360, I mean it's just 60. So that's negative 90. Alright, so that's a negative 90. So if I add 360 again, then I get my 270, right? So these are coterminals too. So secant of 270, that'd be down here. So that's 0, -1. My distance r is still 1. And then cosecant is r over y. So that'd be -1. Alright, so those are all the examples for dealing with just your quadrantal angles. I don't know how to say that, pronounce it correctly. So there they all are, right? And here they're all examples. So some of them that aren't exactly on the x-axis or y-axis, eventually they will be, right? You just got to find what is that coterminal.